Right, what we have to try and do here is we have to try and balance the following reaction by applying oxidation numbers between sulfur, chromate, and this combination, protons, sulfur dioxide, hydroxide, and chromate in this setup here as well. Now, thing is, these can change as you need them, right? That's the most important step with this one. This is a tricky one, so we can add water and protons as we need to. Right, so that's the important step. So what we'll first start doing is we'll apply oxidation numbers to each of these atoms. Now, easiest one here is sulfur. Now, sulfur on its own has an oxidation state of 0. The sulfur atom on its own has an oxidation state of 0. Okay, underneath. Now, over here as sulfur dioxide. Now, sulfur dioxide is slightly different. Sulfur dioxide is in the compound with water. Each water produces -2 charge. 2 times -2 is -4. So sulfur plus what gives you a charge of 0? Well, +4 would work for that sulfur atom there. So this sulfur atom has an oxidation number of +4 on it. So if we draw the molecules in, right, and our oxidation numbers, so sulfur on its own, the atom itself, has an oxidation state of just 0. While sulfur dioxide in the compound has an oxidation state of +4, so we have to go up here. So sulfur dioxide, SO2. So we'll put a little dot on the actual atom in interest. So sulfur dioxide has an oxidation state of +4, right? So as sulfur goes to sulfur dioxide, what happens is it's actually going upwards. It's being oxidized. So it's getting more positive. So each sulfur atom, as it moves upwards, SO2, each sulfur atom loses 1, 2, 3, 4 electrons every time, right? So that's just one rule we're going to have to come back to. So each sulfur atom loses 4 electrons every time. That's that aspect looked at, right? So let's look at chromium in the two different setups. So we have chromium here with an overall charge of -2 on it. Now, I can put this aside. Now, chromium here overall has a charge of -2. Here, -2. And then there's 7 oxygen atoms, and each oxygen atom contribute -2, so 7 2s are -14. So you have 2 times Cr is -14. Add 14 to both sides, which is happening in this step and this step. 2 Cr is equal to 12, and Cr is equal to +6. So in this case, Cr2O7 -2 has an overall oxidation state of +6. So Cr2O7 -2, the atom on it in this has an oxidation state of +6, right? So that's why it's in line with this +6, right? So we'll come back to this now in a second. I want to look at this actual chromium setup that's over here. Now, in this case where it's slightly different, the overall charge is 0, right? And that's why there's a 0 there. Now, you have 3 multiples of oxygen, 3 -2s are -6s, so you have 2 times chromium -6 is equal to 0. Add 6 to both sides, right? Add 6 to both sides. Your 2 times chromium is equal to 6, divide both sides by 2, chromium is equal to 3. So in this case, the chromium atom, Cr2O3, has an oxidation state of +3. In this case, the chromium atom has an oxidation state of +3 as opposed to +6. Right, so you got your 4 different species as they move out throughout the reaction. So in this case, as the chromium atom from start to finish with an oxidation state of +6 goes downwards, right? Each chromium atom is reduced. Its oxidation number is reduced by 1, 2, 3 electrons. It's becoming more negative as it's going down. So I have my 2 setups now. So those are the differences. So this oxidation number is going down, it's being reduced, and this one here is being oxidized. Each chromium atom is being reduced by 3 electrons. Each sulfur atom is being oxidized by 1, 2, 3, 4 electrons, right? And we're gonna come back to that sheet now in a second. So I can move these oxidation numbers out of the way. So let's look at the first reaction here, the reduction reaction, and we'll start balancing that out now. Okay, so we're going to go to the chromium. Now, we said with the chromium reaction, each chromium atom as it moves along, we said for each chromium atom as it moves along from here to here gains 1, 2, 3 electrons as it moves down. So that's for every chromium atom. So it needs 3 electrons as it moves from left to right. So in this case, it has an oxidation state of +6, the chromium atom, and in here it has an oxidation state of +3. So each chromium atom is reduced by gaining 3 electrons, but we have 2 chromium atoms, so we have to double that. So if each chromium atom produces 3 electrons, well, double that, which is going to be here, we're going to produce double the amount of electrons. So we would need 6 electrons to go from this to this, right? That's what's needed. We need that. So that's the first part. Now, what we need to do is we need to account for the overall charge in the species. So that's the overall charge in the right hand side is 0. The overall charge is -6 -2, which is -8. So I need to account for the -8 charge overall and bring it up to 0. So what we can do and what we need to remember is we can add water and protons, and this is what we're going to add now, protons as we need to. So what we're going to do is we're going to add some protons in here. Okay, so what I'm going to do is I'm short of -8, so this time is I'm going to add 8 protons in on the left hand side. I'm going to still have my 6 electrons as I did, and now I need to just write down my chromium in its form like this, Cr2O7 -2, and then I'm going as far over on the right hand side as this, Cr2O3. Now what I need to do is I need to balance the oxygen atoms, right? This is the next step. I need to balance the oxygen atoms. And remember that rule, we can add and remove water, and we can add and remove protons as we need to. So right now we need to actually account for some water. So what I'm going to do on the right hand side here is I'm going to just write H2O. Now I'm going to add them as I need them. Now, I have 7 oxygen atoms on the left, and I've got currently 3. So I'm 4 oxygen atoms short at the moment. 4 by oxygens is 4 oxygens, and 3 is 7 oxygens. The oxygen count is grand. 4 by 2 is 8 hydrogens on the right, 8 hydrogens on the left. I'm grand. So what I have here now in this setup that's below, I have here of Cr2 is my first half reaction. So this is what's going to be accounted for when we go from here to here, right? This is what's going to be accounted for when we move. So what we're going to do is we're going to work on the next half reaction. Okay. And the next half reaction is when you went from sulfur of an oxidation state of 0 to sulfur of an oxidation state of 4. It moves from sulfur to sulfur dioxide, it loses 4 electrons. So on the right hand side over here, I'm going to have 4 electrons. 4 electrons on the right hand side over here. So now the part that makes this question slightly different is we need to account for the overall charge like we did in the past with the reduction reactions. So what we do at this point is we look at the overall charge in the species. Well, overall there's a 0 here and there's a -4 here. So currently the overall charge is -4. And over here, the overall charge is 0. So I need to go from -4 and what will give me 0. The only thing that I could add to -4 would be protons. We are putting protons in pink today. I'd need to add 4 protons in. And then that will account for the overall charge, right? So that's that part done. The overall charge part's accounted for. Now what we're going to do is we're just going to keep this to the same format going. Now we need to balance the oxygen atoms. Now notice there's no oxygen atoms on the left hand side. So what we're going to do is we're just going to, and this is the trick, I'm just trying to give you a process you can always remember. We can add water and protons as we need to. So what we're going to do is I'm just going to add water on the left hand side as opposed to saying it's coming from the chromium compound. We're just going to say we're going to add water in, right? So just add water in, H2O. H2O. Now, oxygens on the right. I have 2 oxygens on the right, so big 2 there on the left hand side then. So I have one sulfur, 2 oxygens, 2 oxygens, 2 by 2 is 4, 4 protons in the left, 4 protons in the right, and that's my other half reaction accounted for. Now, at this point, I have 2 half reactions. I have this one and the one after it. So I can just draw a line. So I have sulfur. What I'm going to do is at this point, I need the same amount of electrons on the left-hand side and the right-hand side. So to do at this point is I look at the electron count here and here. Now, multiples of 4. 4 is a 4, 4 is rich, 4 is a 12, 4 is a 16, 6 is 6, 6 is 12. So what I need to do with the top line is we need, right, for this to work, we need so many multiples of this line and we need so many multiples of this line. That's the trick, right? So I need to get this to a 12. So if I multiply that by a 3, so if we multiply this by a 3, and if we multiply then this line, we multiply this line by a 2, we're going to get 12 electrons and we're nearly home and dry. It's the same amount of electrons, that's the trick. So I'm going to draw my line underneath, make them the same amount of electrons. So I'm going to multiply the top line by 3. 3 times electrons for a bracket, and then I want 2 multiples of this line of water. Now, this point we start multiplying it in. It's called the distribution rule. Draw my line, just like simultaneous equations. The process of it's very similar. So then I have 3 by S is 3 sulfurs, 3 by 2, 6 lumps of water. I'm left with 3 by sulfur dioxide is 3 sulfur dioxide. 3 by 4 is 12 protons. 3 by 4 is 12 electrons. On the right hand side, that's a proton. Then I have 2 of these chromates in this complex here. So I have then 2 chromates, 2 6s are 12 electrons there, 2 by 8, 16 protons there. 2 by this chromate stuff, it's 2 Cr2O, 3. 2 4s are 8 H2Os. Now, we cross off those and we drop the components accordingly on the left hand side. But we have also 8 waters on the left and 6 on the right, on the 8 on the right and 6 on the left. So what we do at this point is we're going to take 6 waters away from both sides. Right? So they cancel. We have 2 H2Os on the right. That's accounted for. 12 protons on the right, and I have 16 on the left. So what I'm going to do is I'm going to take, at the same time, I'm going to take 12 protons away from the right and 12 protons away from the left. So 4 and 2 is 6. So 4 protons on the left. Okay, that's those accounted for there, and that comes up there. 3 SO2s. That's gone. 2 chromates. That's gone. That's the whole right hand side accounted for. Waters are gone. Protons are accounted for. I have 3 sulfurs, and I've got 2 of these chromate things. I got 2 Cr2O7 minus 2. 3 sulfurs. Now, this point, the reaction looks very similar to the one in the very beginning, but the difference is there's no H2Os on the right hand side. So we've got 2 H2Os over here. Now what I'm going to do is I'm going to take 2 protons away from the right hand side. Okay. And what the right hand side will start to look like, very similar to this, is if I take 2 protons away from the right and 2 protons away from the left, right? The left hand side is left with then 2 hydrogens, right? So if I take 2 protons away from the right hand side and take away 2 protons away from the left hand side, both sides, that's that done. If I take 2 protons away on the right hand side, I'll be left with 2OH minus. We're still left with this chromium stuff. 3 sulfur dioxides. 3 sulfur dioxides on the right hand side. I'll be left with 3 sulfurs on the left, 2 chromium things on the left. So I have 4 chromiums on the left, 4 chromiums on the right. I have 2 sevens, I have 14 oxygens on the left, and I have 2 by 3 is 6, and 6 is 12, 13, 14 oxygens on the right hand side. I have 2 hydrogens on the right, 2 hydrogens on the left, 3 sulfurs on the right, 3 sulfurs on the left. The whole lot's balanced out then. So going back to your original question, then you're left with, there's 2 there in the chromate. So then go back to the original question, there is 2 in the chromate, 3 in the S, 3 in the sulfur. Done. 2 in the protons. That's done. 2 on the chromium on the right hand side. 3 on the sulfur dioxide. And 2 on the hydroxide out in front. 2 hydroxides. So the trick is when you're oxidizing your substance or reducing your substance, you can add water and protons as you need to. When you need to account for the overall charge, that's when you're introducing protons. And when you need to account for oxygen atoms, you introduce water. So that's your half reaction.